Now we're going to talk about the new topic, and it's connected with the drilling and the invasion of the drilling mud into the formation. Let's look at the figure. So imagine that this is your productive layer. That's our sweet spot, and we're gonna drill to that formation. It's shown by these red lines. These black lines show us the drilled well, and that is the drilling bit. After a certain time, our drilling bit crosses the top of the formation. We know that during the drilling, we have the circulation of the drilling mud. We push that drilling mud into the drilling pipes, and then it washes away to clean the bottom of the well and to prevent the damage for the drilling bit. Simultaneously, we know that we do have a kind of a drilling mud pressure inside the well. And we do have a kind of a reservoir pressure inside the formation. And in case if the drilling mud pressure higher than the reservoir pressure, we're going to have the drilling mud penetration into the formation. Once the drilling mud penetrates into the formation, it pushed away the original reservoir fluid. So our situation changed a bit. We are creating three types of the zones. That's the flushed zone, shown with green, invasion zone, shown with brown, and the uninvaded zone, the rest of the formation. In the flushed zone, the drilling mud completely replaced the original formation fluid. In the invasion zone, the drilling mud is partly replace the original fluid. And the uninvaded zone. In this zone we have the original reservoir fluid, and our drilling mud did not penetrate onto that deep. And let's look at this model by constructing this kind of graph. On the y-axis we have the electrical resistivity, and on the x-axis is the distance inside the formation. Let's check the first example in case if we have the oil saturated formation originally. Once we drill through that formation, in the flushed zone, oil was replaced by the drilling mud. So let's assume that our resistivity in the flushed zone looks more or less like that. In case of the oil in the formation, the resistivity of the formation gonna be much higher than the resistivity of the flushed zone, because the resistivity of the oil much higher than the resistivity of the drilling mud, in case if the drilling mud is the water based. So in uninvaded zone we're gonna have higher resistivity, and in the invasion zone we have a kind of a transition. So our resistivity gonna looks just as it's shown on the figure. In case of the water saturated formation, in the flushed zone we have the same situation, because the water, original reservoir water, was replaced by the water from the drilling mud. So we got more or less the same resistivity. In contrary, in case of the water saturated reservoir, we're gonna have the same story in the flushed zone, because original reservoir water was replaced by the drilling mud. In case of the water saturated reservoir, the salinity of the formation water usually much higher than the salinity of the drilling mud. In this case, the resistivity of the water in the formation is much lower than the resistivity of the water in the drilling mud. For that reason, resistivity of the uninvaded zone is lower than the resistivity of the flushed zone. And we're gonna have this kind of situation. So if we're gonna compare these two cases, in case of the oil, the deeper we are in the formation, the higher the resistivity. In case of the water-saturated formation, the deeper we are in the formation, the lower the resistivity. And that leads us to the possibility of measuring the type of the saturation of the reservoir. In case if we're gonna measure the shallow resistivity and the deep resistivity, and the deep resistivity gonna be higher than the shallow resistivity, we can find out that it's hydrocarbon. In case if deep resistivity show us lower readings than the shallow resistivity, we're gonna have water in the formation. That's what can be done by using different types of the logs. For example, lateral log deep and the lateral log shallow. The same story can be done by using VKeys, which is specially designed induction tool